Hello, my friends. তোমরা সব কেমন আছো? আমরা আজ ক্যাপাসিট্যান্স এন্ড ক্যাপাসিটার্স এর উপরে কিছু প্রশ্ন আলোচনা করব। The remaining problems on capacitance and capacitors will be discussed today, which are of MCQ type. Two large metal plates are placed parallel to each other. The inner surfaces of plates are charged by plus sigma and minus sigma. That is coulomb per meter square. This is the surface density of charge. If the outer surfaces are neutral, so the required diagram is drawn here. Inner surfaces. This is inner surface. Yes. This is plus sigma. This is minus sigma. So where epsilon zero is the permittivity of the free space. So E, what is E? E is the electric field, which is acting from plus to minus, you know it. And for long, large metal plates, the problem says that the metal plates are large. So resultant electric field, E net, resultant electric field equals to sigma upon twice epsilon zero minus of minus sigma upon twice epsilon zero equals to sigma upon epsilon zero. So this answer B. Answer B is a correct answer. Also, outside the plates, there is no charge because if the outer surfaces are neutral or earthed, outer surfaces are neutral or earthed, so there is no charge at the outer surfaces. বাইরের পৃষ্ঠে কোনো আধান নেই, সুতরাং বাইরের পৃষ্ঠে তলমাত্রিক ঘনত্ব সেটাও জিরো হবে। সুতরাং সিগমা জিরো হলে ই ইকুয়ালস টু সিগমা আপন টুয়াইস ইপসাইলন জিরো, এটাও জিরো। সো অ্যান্সার বি ইজ অলসো দ্য কারেক্ট অ্যান্সার। Here is right sigma upon twice epsilon zero. Why? It comes from Ampere's theorem that for large metal plate, suppose this is a large metal plate, so suppose this is a suppose sigma is the surface density of charge for this metal plate, and a plane, and a plane is taken into account which passes from this large plate. So suppose the area of the cross-sectional area of the closed plane equals to A. So inside this area, the charge present equals to sigma A. Charge present equals to sigma A. And suppose here is E and here is also E. So we can write by Gauss theorem as E for these two surfaces, E into twice A equals to 1 by epsilon naught into Q equals to sigma A upon epsilon naught, and so E equals to sigma upon twice epsilon naught. Why you taken here as E in this direction and also E in this direction? Because if the net electric field is E and E minus E equals 0, but this is not the case. The case is what? The case is that there is something electric field. So, and scalar quantity and the scalar value of E is not a scalar quantity. Scalar value of E is not vanishes. So here E is the electric field and here E is the electric field for Gaussian surface. We write down for this. And because this is E and for this and the surface for this, electric field for this surface and the surface, this is at the right angle to each other. So this part will vanish because E dot ds equals to E ds cos theta. If theta is 90 degrees, then it will be vanished. So for this part, the longitudinal part, this will vanish. And so here E is in this direction and surface, this surface, the surface vector also in this direction. So E ds equals to E ds cos 0. E implies E ds. So this result comes to us. And for in this direction, E applies because we know for a system of two charges, here is plus Q, here is minus Q. So lines of force goes from this end to this end and this end to this end. So and this is the free space. So from positive side to negative side, the lines of force approaches. So this is the case. And in case of system, in case of dipole, this will get from negative to positive side. So for large metal plate, we have find out that sigma by twice epsilon 0 is the electric field for the positive end and minus sigma upon twice epsilon 0 is the electric field for the negative end. And the resultant of these two equals to this minus this equals to this. If this is plus, then it will vanish down. it is not the case. Physics is a subject which is based on some matters. This is the second problem. This is nothing but an arrangement of some capacitances. We have to find the equivalent capacitance between the 2 points P and Q. So, let us start. This is equivalent circuit. First, we attack this portion. This is in parallel combination. We know for capacitance in parallel combination, the resultant equals to summation of the two capacitances. So the resultant of these two CC we get as twice C. Now we take this portion for consideration because these two capacitance is in series connection. So the resultant will be the reverse of resistance connection. So we can write by equivalent circuit diagram as C dash equals to, what is the value? C dash can be given by this 1 by twice C plus 1 by twice C equals to 1 by 2 by twice C equals to C. So C dash equals to C. Now attack this portion, we get C dash equals to this is first these two parallel connection we get as twice C. Now this twice C series connection we get this. Now for these two parallel connection we get also here for these two parallel connection we get here as twice C. Now these two for series connection we get here as for these two we get by this formula as C. So this is C. Now for these two parallel connection we get thrice C because these two are in parallel connection. So capacitance will be added. So the answer, so the equivalent capacitance is the thrice C, which is answer equals to A. A capacitor of capacitance twice F is completely charged with a battery of EMF 5 volt. If the battery is disconnected, now the battery is disconnected and a 6 ohm resistance is connected across the capacitor. So let us draw the diagram. This is the diagram. Here the capacitor is charged fully by 5 volt battery, and then it is disconnected and resistance is taken across the capacitor. This is the system by which the capacitor and resistor is connected. So the standing equation for solving the problem equals to Q equals to Q0 e to the power minus P upon CR. So Q is equal to Q0 e to the power minus 12 upon 6 into 2. And what is Q0? Q0 equals to C into V. So Q0 equals to 2 into 5. So 10 coulomb. Putting here we get 10 into e to the power minus 1 equals to 10 by E Q equals to 10 by E coulomb. So answer A. The problem done. But why this equation taken into account? When the battery is taken out, then the voltage difference in between P and Q equals to 0. And this voltage, when the battery was placed here, then the total voltage is distributed through C and R combination. So here Q by C plus Ri. If I is the current, then Ri is the voltage through resistance R, and voltage through capacitance equals to Q by C, when Q is the charge after time T. Due to battery taken out, the charge of capacitance will decrease in course of time, and for a certain instant this equation holds good. So R dq by dt equals to minus Q by C, implies dq by Q equals to minus 1 by CR, implies integrating both sides we get log Q equals to minus T upon CR plus log C dash, where this is the arbitrary constant. Applying boundary condition, here we get when T equals to 0, then Q equals to Q0. When T equals to 0, then Q, charge on capacitance, is Q0. So we can applying this, we get log Q equals to minus 0 plus log C dash, implies C dash equals to Q0. So after all we can write log Q minus log Q0 equals to minus Q by CR, implies log of Q by Q0 equals to minus T by CR, implies Q upon Q0 equals to e to the power minus CR, e to the power minus T by CR. And after all we get Q equals to Q0 e to the power minus T upon CR. This relation applied here to solve the problem. Number 4 problem is also a capacitance diagrammatic problem. In the circuit shown in the figure, this is a circuit which is shown in the figure. The potential difference of 10 cube volt is applied between the points A and B. এখানে 10 কিউব ভোল্ট পোটেনশিয়াল ডিফারেন্স অ্যাপ্লাই করা হয়েছে। the charge of 0.75 millicoulomb is stored in the combination of so equivalent capacitance is to be found out first, because it is said that in the combination of capacitors you have to find the equivalent capacitance of this combination first. So equivalent, what is the equivalent? This is in series connection, so we can write this is also in series connection. For this series connection, the resultant of these two will get by parallel connection. How? Suppose this is C dash, suppose this is also C double dash, and this is C. We have to take the diagram first clear. How? This is series connection and this is this connection, this capacitance is connected to A and B. But these two capacitors are out of this circuit. So this is the resultant of these two which is out of this circuit, and these two and these two, this and these two are with parallel connection, so given also here. So this is the equivalent of this circuit, and this C dash will be how? 1 by C dash equals to 1 by 2 plus 1 by 2 gives you 1, so C dash also 1. So C dash equal to 1, and here C double dash equals to, so C dash equals to 1, so you can write as here as 1, and C double dash, how C double dash? C double dash also by this, in this way, 1 by 2 same. So this is also as 1. So 1. And by virtue of this, again we can, this in parallel connection, so we can write this as 1 plus this for these two parallel connection, the resultant will be summation of these two. Now this is in series connection, so the resultant of then so C dash, C double dash, C triple dash, the resultant equals to 1 plus 1 by 1 plus C, means 1 plus C plus 1 plus 2 plus 2 plus C upon 1 plus C. So C triple dash equals to 1 plus C upon 2 plus C. So C triple dash equals to this. Now, according to the problem, 1 plus C upon 2 plus C whole into 10 cube. This is the charge of the equivalent capacitance. This is given as 0.75 millicoulomb, means 10 to the power minus 3 coulomb. This is 10 to the power minus 6, because this is in microfarad unit. So 10 to the power 6, this in 10 to the power 6 equals to in farad unit, and 10 cube also given in volt unit. So this is after all in coulomb unit, and this is also in coulomb unit. We have to balance both sides. Then we can write 1 plus C upon twice plus C equals to 75 upon 100 equals to implies 4 plus 4C equals to 6 plus 3C implies C equals to 2. So the answer is A. Or this problem is the charge distribution between two capacitance. According to the problem, two insulated conductors. While insulated, there is no leakage of charge from the capacitors, for which insulated wire is applied are C1 and C2 respectively, and charges given as Q1 and Q2 respectively. Then their potentials are V1 and V2 given respectively. Now the two conductors are connected using a thin conducting wire. সরু তার দিয়ে ওদেরকে জয়েন করে দেওয়া হলো। ওই দুটো অন্তরিত পরিবাহীকে সংযুক্ত করা হলো সরু তার দিয়ে, so that both the capacitor conductors have the same potential V. We have to find the value of V. This is the problem based on the constancy of charge. Before connection, the total charge was Q1 plus Q2. After connection, the total charge is also Q1 plus Q2. Because after pairing, the potential of both the capacitors are V. So we can write as Q1 plus Q2 equals to V times C1 plus C2, because their potential is V after varying. So this now Q1 equals to C1 V1 plus C2 V2 according to problem. C1 plus C2, then problem solved. So V equals to C1 V1 plus C2 V2, this divided by C1 plus C2. So answer will be C. We face another problem as two spheres, two concentric spheres. Two concentric metallic spheres are taken into account. According to problem, outer sphere is given a charge of plus 30 ESU and the inner sphere is grounded. Suppose the outer sphere given charge as Q1 plus Q2 equals to 30 ESU, where Q1, this is Q1 and this is Q2. The outer sphere of outer side have gathered a charge plus Q1 ESU, and the outer sphere inside the outer sphere, the charge gathered by the inside portion is Q2 is considered. So this, and for this Q2 there is a minus Q2 charge due to induction, due to বাংলায় বলে তড়িৎ আবেশ, due to charge induction. Why induction? Here is plus Q2 charge, here is another metallic plate which has no charge. So this charge and this charge, there is a free space, minus Q2 charge will be induced. This was obtained by our electrical induction process. In the outer sphere, there is a two charge distribution. The inner side and outer side of outer sphere, both of same charge plus charge. One is distributed Q1 and another one is distributed to Q2. It is thought as, so by this we can write this, and here is minus Q2. So the voltage, suppose this is B and this is A. So VB equals to minus Q2 this is radius of 4 C and this is the radius 6 cm. Minus Q2 by 4 plus Q2 upon 6. Minus Q2 for this we get for a spherical body if the charge present outside the sphere is Q, then at the center point its voltage will be total Q upon the radius. And for this also Q2 upon, for this There is a Q2, so Q upon this. So we can write, but this is equal to 0 because it is grounded. So we can write this is for minus Q2 for this charge inside the inner sphere, no charge, and the outer sphere having charge 30 SU. So this, after this we can write as minus Q2 by 4 plus 30 because Q equals to 30 equals to 0 implies minus Q2 by 4 plus 5 implies Q2 equals to 20. So the charge on the inner sphere, the charge on the inner sphere, the charge on the inner sphere equals to minus 20. So answer B is the correct one. And now VA, what will be VA? This is nothing but Q1 upon 6 equals to 30 minus Q2 upon 6 equals to 10 upon 6. So VA minus VB equals to 10 upon 6 minus 0 equals to 10 upon 6. So capacitance C equals to capacitance C of the total system will be equals to 30 divided by 10 by 6 equals to 18. So C equals to 18 ESU unit. So answer D also correct one. Here is the calculation of VB and VA. VB is grounded, so this is 0. How this obtained? This is minus Q2 for inner sphere, so at the center this will be minus Q2 by 4 plus this is Q2 and Q1 for the outer sphere. The total charge will be added here because there is total charge Q, so this by this, or from which we get Q2 equals to 20. And VA, what is the VA? So when the charge present outside the, when the charge present at the outer sphere, then total charge is 30 SU. So at center point there is no charge of inner surface. For outer surface at center point, total charge for the outer sphere, the outer surface Q1 and not taken for Q2 because this Q2 is going into the electric induction. So Q1 by 6 after which we get as C equal to 18 SU. This is all about for today's class. So I request you to subscribe my channel, which is known as Vidyut Flow, as far as possible. And we again start the next day. Thank you to everyone.